Hey, folks.
Hi, Andrea. Hi, Alex.
Hey, Ari. Hey, Alex. I think it takes everybody a minute to connect to audio on this.
Hello, Andrea.
Hey, how's it going?
Going well, thanks.
Andrea, I have that comforter.
It's so bright and colorful.
I love the colors.
Yeah. It sleeps
Beloved by dogs, apparently.
so now it's on the guest room bed.
Nice. I was waiting for the room to fill up.
How you guys doing?
Hey, Ari, how
Hey,
you
John
doing?
Michael.
JM?
What's happening?
What a trooper, Logan.
In the car on his way to a date with his wife, or his fiance, that is. Hey, Shruti, how are you?
Good. How are you doing, Alex?
Good, thanks.
Hi, Brian.
Yeah, Brian, welcome.
Thank you.
So it's 8:02. Welcome everybody. Thanks again for joining. We are lucky this week to have Brian Kelly with us, and we'll introduce him in just a minute. But first, we wanted to get through a bit of housekeeping. And the key item there is that we are approaching our regional summit in Lisbon, Portugal. The sustainability track is set for that. So if you are a selected speaker for that track, just a reminder that the submission deadline for your draft presentation is Monday on the 18th. So make sure that you're ready for that and ready to get it in on time so that there are no hiccups. We look forward to having everybody who's already on the schedule. We've got a great track organized, thanks to everybody who contributed to vetting proposals and putting that track together. Shruti, anything else or anyone else on the call for housekeeping and administrative issues?
I think nothing else in particular. I think both the work streams that started last month, I just wanted to mention that they'll have their session 2 in this month, which should likely already be on the calendars. If not, I'll check once, but this will be like the second session for both the new work streams that started for carbon accounting and circularity, and the work stream for carbon label standardization.
Yep.
So just a reminder to folks about that.
Yeah. And we are trying to say carbon disclosure because there was a hot debate in that group about
Not label. Yes.
Yeah, exactly.
There's a strong
About the
allergic
value.
reaction to the notion of a label. Yes.
Exactly. Yeah. The label is it's animating on both sides. I think the idea here is that a disclosure is a generic enough term that we can describe a number of different outcomes there, and it doesn't imply perfect comparability one to the other. So more to come on that, not to sidetrack us. But thanks, Shruti, for the reminder that we've 2 sessions in on that one, and should be at the second session as well for circularity. So with that, let's turn it over to Brian. Brian, thanks for joining us as this month's speaker. Brian Kelly is the security project lead for OCP and is also at Microsoft Azure, partner software engineering with Microsoft Azure. And you can introduce yourself and do a better job than I just did. But we're hoping that Brian can give us some updates on the current work streams and initiatives in the security project, and in particular work related to data sanitization, which is something that we've talked a lot about in this group over the course of the past year, and is of course relevant to the new circularity work stream that is now getting up and going. So a lot of that work being led by Ari and JM. So hope to have a lively discussion on that topic in particular. But Brian, if you wouldn't mind introducing yourself and then just giving us an overview as to what's going on with the security project, that would be great.
Yeah, absolutely. Thanks a lot for inviting me here today to give this talk. I think there's a lot of common overlap, or not overlap. That's the wrong word. Maybe a complementary work in driving security forward to the state it really needs to be, mainly around renewability of security. We are going to talk in my talk today. I have some slides I'll share. I want to talk just in general about security and some of the challenges of the past and of the present with sustainability, and then we'll get into the specific storage and arrays problems that we have and how we'd like to move that forward. So just let me figure out here how I share my screen. All right, got it.
And Brian, could you just give us some quick background on your day job before we dive in?
Yeah. So my day job in Azure in Microsoft is I run a hardware architecture team, and I'm responsible for hardware security in Azure. So I lead a team of hardware architects and firmware architects as we deliver next generation infrastructure into Azure. So really looking at current problems and delivering the next generation systems is my day job. And then I co-lead the security project with Jeff Anderson from Google, and we have weekly calls in the security group about just technologies and changes and things that need to happen in the ecosystem. There's a lot of synergy across CSPs, like cloud service providers, when it comes to security. We all procure systems from the same ecosystems and suppliers, and we have the same pain points when it comes to foundational security properties, when it comes to renewable security. So yeah, we're pretty well aligned, and help the ecosystem in moving some of these things forward. And we have a great group inside the security project. Weekly, we have maybe 20 to 30 people join the call. A lot of active participants from the ecosystem. So it's a pretty vibrant space right now. So with that, I'll jump right in. I can't see. I'm kind of working from home today or this afternoon, so I can't see if anybody has a question. So just feel free to cut me off, and if anybody sees a hand up or something else, just interrupt me and let me know.
Yeah, it's a small enough group or a manageable enough group that I would encourage people to just speak up to take part in the presentation rather than using the chat.
Yeah, love it.
Yep.
Thank you so much. All right. So with that, let's, whoa, we jumped maybe too far in. Let's see what's happening here. Might have to come out of this.
It's challenges. We like that.
Yeah, jump straight into the challenges.
Yeah.
Let me just take it back a step. If I can. Oh my goodness, it went to the very end. Almost to the end. So a little bit of a spoiler. All right, about me. So sustainable security challenges is where we'll start off. So a general problem we have with hardware is security has some persistence in hardware, and it has a purposeful persistence when we think about capabilities, security capabilities like anti-rollback. So what anti-rollback is you might have firmware version A, B, C. And as you move from firmware version A to B, there might be a vulnerability in A, and you don't want the component to be able to roll back to A. So the things that people have historically used to prevent this have been things like fuses, where there's a finite number of these resources, like there's limited resources inside the hardware, and they essentially blow those hardware fuses to prevent anti-rollback. And that's one of the big things that is fuses and these limited resources is one of the big things that impacts not only sustainability, but what we would call renewability of hardware, is it can be like redeployed in other scenarios where the vulnerability that was present in A, when it's deployed in another scenario, that vulnerability doesn't exist. And these fuses have been a kind of a pain point, especially in cloud operations, where sometimes defects are slow to manifest, and the cure is worse than the disease. So if you move from like firmware version A, like I said, to B, and then you blow a fuse that prevents you going back to A, well, if later B manifests with a worse condition to A, you're then in a position where you have to rush again to C because you can't roll back to A. So these are some of the scale challenges that we have that also impact this security persistence that devices have had in the ecosystem for a long time. So what we generally push for in the security work group is what we call renewable security primitives, where there's no real hard setting like one and done. But we have a series of renewable options where security keys, if they get compromised, can be regenerated, and really extending anything that has a limited resource to have sufficient number of resources to support the lifetime and what we call the afterlife, or the second and third life of the product if it gets sold into a circular economy. So how do we, in the security group, how do we move this ecosystem forward? What we've been driving a lot of, and we have a lot of participation from a lot of big silicon manufacturers, typically, Intel, AMD, NVIDIA, all participants. ARM is a very active participant in the security work group, as well as others from storage. And I don't want to just call out individual companies because there's so many that participate. But we come together and we define specifications and guides, and we publish those specifications in the security work group. And those specifications, of course, we promote, hey, renewable security, scalable security. But the challenge with these is, and they've been slow to adopt. We've published specifications since the security work group has been around since 2016. We quickly ratified specifications in 2017. We're still seeing devices in the ecosystem that haven't quite adopted, or they're always on roadmap for the next generation of device. They do partial implementation. We also see challenges with consistency. Maybe the specs are really badly written, I don't know, but we see challenges with consistency. And that one is killer, and we'll get into what inconsistency means in the ecosystem, and from a security perspective, what a kind of a detrimental effect inconsistency has on the ecosystem as a whole. So in recent years, as of like last year, we started to pivot a little bit away from just doing specifications to providing a robust implementation. And we decided that, you know, we understand that not every company's strength is going to be in designing security. Not everybody's strength is cryptography. And we decided that, hey, the specifications that we
I think that may be background noise.
okay.
Ricky, I don't know
Yeah.
if you could mute your phone.
Yeah, we pivoted away from just doing specifications to also providing a robust implementation. That robust implementation is in the form of both silicon and firmware. So one of the first forays into that was a project we called Calyptra. And Calyptra is a root of trust. It's an open source silicon root of trust that gets designed into SoCs, and it provides that foundational security. And the goal for us in doing that was to drive consistency of security primitives, because these security primitives, we believe that they're of course foundational, but they're all standardized. You know, cryptography is kind of a specialist field in that it's either right or it's wrong. And the first rule of cryptography is you don't write your own cryptography. So because the math is somewhat complex. So we believe that at that level, that is like table stakes and is consistent. It's not an area you can differentiate. It's heavily standardized by NIST, by common criteria, and there's no real room for standardization. In fact, differentiation in these security primitives is a very bad thing, and it's frowned upon. And that what we want is to have these common security primitives and provide consistency across it. And then, of course, we then provide transparency on these security mechanisms. Of course, being open source, you get tremendous transparency, builds trust and confidence in the product. And where we see a lot of overlap with our sustainability goals is actually in this consistency bucket. Like I mentioned earlier about fuses and how keys get stored. And as we move away from persistent burn-in security to more renewable security primitives, getting that consistency across devices is absolutely key. Because we can come out here in OCP and we can all work together in the community to develop something. But if our peers and even our competition, if they try to develop the same thing and do it in an inferior way or do it in an inconsistent way that it compromises the brand of what you're trying to accomplish, and that in turn can impact perception on a mechanism. And this is going to be a little bit more critical as we get into the stuff specifically around storage and what we want to do for storage. So it is, the Calyptra thing was one into driving consistency and transparency into the root of trust mechanism in devices. Now, it's not a one size fits all. There's more we have to do. And not all devices are stateless. So that's a key one. You can kind of see where this is going, that we don't have all the stateless devices. Some devices store data. Storage has been one that is particularly problematic from a sustainability perspective. And it's problematic not necessarily because the standards don't exist. It's problematic a lot of the time because of the consistency and implementation. So one of the things that we've started to do with, with Google, Microsoft, Samsung, and other storage providers have started to work on this thing called layered open source cryptographic key management. It's called LOCK, which is why the letters there are bolded. This is going to be similar in many ways. It actually builds upon Calyptra. It's an extension to Calyptra, where we're working on a key management engine which solves a lot of the challenges with the implementations of crypto and key management in storage devices. Key management in particular around crypto arrays. And a goal here is to standardize the mechanism, and of course make sure it's a very robust mechanism, it's transparent, and people understand how it works. And it ensures that things like that crypto arrays, things like key derivation, how keys are managed, they're all implemented consistently and to a very high standard. So this again will be an open source silicon and firmware project, which is underway, and it's still going to, I'd call it in the early phases of design, but it will rapidly move to implementation once we close out the design.
Question on that lock part. So, lock, you mentioned this particularly with the key management and crypto erase, like that the encryption key is what you're talking about in the drives, right?
Yes.
So
Yes.
Calyptra is to do with the security of all aspects of the drive. So this is like one component within Calyptra.
That's a great question. Calyptra actually fulfills what's called the root of trust capability, which performs attestation, which is really measurement. It provides identity, which is unique cryptographic identity in each chip or each SoC, which is generally in the form of a certificate. It provides that. It provides measurement of the firmware that's loaded into the device, so you can understand precisely and exactly what firmware is running on the device and whether that firmware is secure or not. The device can quote that to you using that certificate, so you know that the information came from that specific device. And then Calyptra also has a key management engine inside it for keys around signing and wrapping. Now, Calyptra is very, very small in size, and it doesn't have a very large key vault. And Calyptra does have some really strong security primitives, such that none of these key material is ever handled in firmware. So if there's a compromise on a device with Calyptra in the firmware, or there's a vulnerability in the firmware, keys never get exposed. The keys are only ever handled in hardware. So all of the logic for Calyptra is actually an RTL, all the key management logic, and the key usage logic is an RTL. Now, with lock, we understand storage devices, like key pair IO and some of these standards, they can potentially have a lot of keys, depending on the number of namespaces supported. So we have to make that logic for Calyptra a little bigger. So when we look at lock and how Calyptra manages device keys, but then when we look at data and data management keys, that's what lock manages, is the data encryption keys. And it makes sure that those are managed using the same primitives. Those keys are never exposed in clear text to the firmware on the device. And when we call an erase operation on those keys, that they're securely removed. When debug is enabled, when the operational life cycle of the drive changes, the keys are securely disposed of. And all of that logic happens in hardware, so that again, compromises on the firmware or changes on they can't impact they can't reveal anything about these keys. Or in fact, if the device is stolen and removed from the server or the data center, those keys are not recoverable. So that's what lock delivers specifically. And lock is one path to make sure that we have trust in the mechanism around what's called crypto arrays. Now, for sins of the past, crypto arrays, for all intents and purposes, crypto arrays is secure and it's perfectly adequate. But because of sins of the past, crypto arrays is inadequate to meet the requirements. In fact, 2 forms of arrays are required. And the 2 forms of arrays are both a crypto and a block arrays. And we'll get into that in a little bit as to why and the history behind why those things are required. But again, it all goes back to that. I don't believe there's anything wrong with the specifications. I believe there's a lot wrong with consistency. And everybody gets tarred when we have, when we have one person that's inconsistent and doesn't implement things in a way or has a buggy implementation. There's a lot of engineering think that some of this stuff is differentiating, and what they don't realize is everybody gets tarred with the same brush. So if you have vendor A and vendor B and they're competing in a market, if vendor B has defects in their implementation, vendor A gets tarred with that same brush, whether their implementation is good or not. From a customer perspective, they don't differentiate. They don't care. They're like, well, it could have the same bug. They don't know. You can go and promise them that it doesn't have the same defect, but for their perspective, it's like, well, I don't know. It could. In future, it could. So all of a sudden, you get into a situation where, it's not good for anybody. It's we'll get into the game theory of that here in a slide or two, but
yeah, Brian, I've said the same thing. If one of us faults, it taints us all. The examples you used at OCP were all SSDs from a few years ago, but not so many years ago. Do you feel the same way about HDDs? And what do you think? How do you compare this to, say, FIPS 140-2 or 3 and common criteria?
I don't know if you recognize the voice, but that's Ari from Seagate.
Yeah, no, I can't see, so yeah, the voice did sound familiar. Yeah, the FIPS and common criteria, those standards are out there, but they're guidelines, and I think it's great that they have those standards, but it doesn't necessarily mean that the device is secure. Like those standards are not going to tell you that your block arrays is implemented correctly, and that parts of the garbage collection that moves blocks, that swaps blocks out, that the swapped blocks are getting erased. There's nothing in FIPS or common criteria that's going to look at that.
Yeah.
And you're right. It's unfortunate, but the way the ecosystem is a lot of people think their implementation is what do they call it, IP or value add or differentiating, and it's like, well, you know what, you may have done a really great job and your implementation is robust, but nobody believes it because your competition across the water, they did a poor job and you're all in the same boat. And yeah, it's one of those things. And this is where we kind of got to establish what's table stakes in market and how do we make sure that it's like a robust implementation, because without that, we're not going to move forward. We're not going to be able to move past the status quo of today. And, I've talked probably through this slide already in it, where we've got, sensitivity on data recovery with storage, with even key recovery for crypto arrays. There's sensitivity around that. Some people have done poor implementation on that, which we're addressing with OCP lock. The other one is kind of like inconsistency has lost the customer confidence, which is really what I'm talking about, the inconsistency part. Then like we're kind of aligned on, this game theory is not well understood, where it's like, hey, like from a CSP, like I'm a cloud service provider. I know if a device vendor has a poor implementation, that it's going to impact the perception of all devices that come in, and it's going to impact the customers that come. And really what we need to be doing as a community in OCP is coming, not looking necessarily at, differentiating right down to the nth degree. We need to establish what's foundational and what's building confidence in
I don't know how to take this breeze, and she didn't take her Allergy noise.
Sorry, background
Yeah.
or?
That's background noise again. Yep.
Cool.
So I have a quick question, Brian.
Sure.
Are you expecting Calyptra on every storage device?
Sammy from
Sam,
Intel.
Intel.
Sammy, am I expecting
Yeah.
lock?
Yeah.
Yeah,
Yeah. Are you expecting Calyptra to be on every storage device?
absolutely. Yeah.
And when you have an NVMe storage kind of over fabric model, how do you see that it's going to be used there?
When we have a fabric,
Right.
like an NVMe over fabrics.
Correct. Correct.
Yeah, like in disaggregation, we still have remote attestation. In fact, most models right now are disaggregated and we have remote attestation.
And also the Calyptra will play into that attestation.
Yeah, it already does. That's one of the core things it does is provides measurements at a TCP.
Okay.
And in fact, earlier today, there was another group, like a confidential compute consortium. They were running a conference, and there was a lot of talks at that on how that attestation works in confidential compute. If it's also free to register on for the confidential compute consortium, and you will be able to get replays of what was said there. But you can go on there and see some of the talks around that. So yeah,
Two folks, including me, have their hands up. So Jim, do you want to go ahead?
shoot.
Oh. Yeah, we heard one of the flows from one of the enterprise OEMs of how they handle media sanitization requirements, and it along the lines of requiring a NIST 888 or IEEE 2883 compliant purge, so block erase, crypto erase, or overwrite, and then they do a full pass overwrite with zeros, and then do this 10% verification or something. But each drive model and individual firmware, they actually did a forensic analysis and sent it to a third-party test house like ADISA or On Track that does physical disassembly and puts the media in a media tester and ensures that one of the media sanitization techniques was effective. And we were hoping that OCP Safe could be some of that third-party firmware validation and checks that a drive that went through the OCP Safe program could have things like the crypto algorithms and implementations correctly identified. And one of the other things that they're doing is having vendors self-report the validation of sanitization that they do have these abilities to do low-level testing of over provisioning, spare area, other things that are not accessible by user space LBA validation. But anyways, yeah, that's again one implementation of an enterprise OEM who has successfully implemented a media sanitization program. With some additional steps. How do you view OCP Safe and how that plays in with all this?
Yeah, I think that's great. We haven't really thought too far ahead. And OCP Safe is launched. It's focusing very much on firmware and base security checks. We haven't taught yet in the storage space. Can we extend that further to do the verification of these arrays techniques? And I think that's a great idea. And I think it should definitely be on the charter. And if there are volunteers to help with that, we'll of course support it in OCP Safe, and find the right certification houses or labs that can qualify devices for that. And give that assurance that, we can call these devices, that pass it, maybe to get a renewable badge, maybe to get a security badge or certification. Yeah, we can definitely look at something like that. I think it's
either way, yeah, we've definitely heard loud and clear from end users that the trust in media sanitization needs to be verified and validated on the individual drive model and firmware level for each device type, just because of all the possible bugs and implementations. But yeah, we wanted to go one step further and actually have the firmware audited in this OCP Safe program. But yeah, obviously the reason why we're here in the sustainability project is that it takes a tremendous amount of energy and carbon to manufacture these devices, and just shredding a 4, 8 terabyte or 16 terabyte SSD. It's just a very, very sad thing. So,
and you know what? It's not all as secure as people think it is. We'll get to that in a minute. But you know, I do like that idea of bringing something like that through safe. I think it could help us to, at least, you know, if we have that program, we can start to draw a distinction between, you know, legacy devices that maybe don't have that, or somebody does a per implementation, so we can start to classify them in a way where the confidence in the arrays operation is brought, because that's what it is. It's a confidence issue.
Yeah, and we want to make sure that it's written. I mean, we'll just say some of these security experts in IEEE SysWig don't believe that the way that the requirements are written in the OCP NVMe SSD spec are really adequate. And you know, I believe that their position is that they have given the feedback, you know, during the spec review. But you know, either way, I do think this would be a good topic to tee up in the OCP security work group. As far as like data sanitization, OCP safe, how would you implement that audit, and what things to look for? Like you said, they're already going through the crypto implementations. So the media sanitization is just, you know, I believe that the one SSD that went through from SK Hynix, it looked like from the OCP safe audit report that it did, you know, at least verify that the sanitization paths did in fact, you know, remove the stuff that is user data and was user data, and the spare area, over provisioning, bad blocks, everything like that. And but that's part of what a crypto race, you kind of need crypto race to work, to make sure that bad blocks are properly sanitized, because they're bad and you can't read them.
Yeah, and we're working on that too. You know, so as I said, lock is kind of one dimension. The other one is you know, I think because of the, you know, the sins of the past, the whole crypto arrays thing, there's two types of arrays too. You know, there's hey, I have a drive and I have a virtual machine, and it's got a sliver on that drive, and that virtual machine, you know, reboots or moves away, it gets migrated somewhere. The quick and easy way to clear that space is, of course, to implement crypto arrays. And then there's the more intensive, hey, this thing is going to leave this secure facility, let's scrub it and do like the block arrays. So, you know, I think because of, you know, sins of the past and different reasons for, you know, key management has been weak. So we've been kind of hit from all angles. The block arrays implementations haven't always been consistently good, and the key management hasn't been consistently great in the past. So now, because of the sins of the past, we have these really onerous kind of requirements. Oh, I bring this one up. You know, there is a lot of consequence for mistakes here. So let's get that out on the table. But because the sins of the past, this is what we're faced with. So most major CSPs are destroying perfectly good drives. That's the reality of kind of where we're at. These things are getting ground up and shredded. And it doesn't matter if you're SK Hynix with like the perfect implementation, everyone's tarred with the same brush as far as customers are concerned. Could there be bugs? Could there be escapes? You know, the sensitivity over data is very, very high. And it's up to us as a community to win this battle. And we can't do it without a community effort. And it has to be something, like you're saying, standardization on these mechanisms, robust implementations, maybe OCP safe is the path for verification of those mechanisms. But we really need to come out with a very distinctive way of identifying drives that are renewable. And, you know, we have some ideas around that. And of course, we'd love to brainstorm on those. I think we need to move away from this model. In fact, this model, you know, when somebody sees a lot of pieces of a drive, you know, when it gets all minced up and it's just dust, of course, it gives the optics of being secure. But you always have the challenge of, well, how do you know that specific drive went through the mincer? How do you know the technician was not doing one in the drive and one in the pocket, right? You know, we can do better than this. And, that's why we talk about, challenges is that is it's not sustainable, doesn't achieve zero trust. And that's where I'm going with the zero trust.
Brian,
if the-
one very quick thing before you're moving ahead. So I actually really like the idea discussed between JM and you of actually having verification of that erase technologies. With respect to lock though, which is only the crypto erase right now, is the idea sort of that, if I am a supplier and I'm a drive supplier and
Mhm.
I haven't implemented Calyptra as of yet, or I'm not, far ahead on that path, can I implement lock standalone, or does it have like a only after they have gotten to the point of implementing Calyptra can they go after lock implementation?
Yeah, you will kind of need both. And, of course, you could start out on your own path to try to imitate, like no doubt about that. But, what Calyptra provides is attestation and identity and, secure boot, transfer of ownership. It has a bunch of features that are kind of complementary, but the fundamentals of being able to cryptographically prove something happened is comes from the root of trust. That's the one that's anchored with the identity that can do attestations and can do attestations of operations. So when we change the operational life cycle, that gets attested in Calyptra. When the keys are getting derived, when they come in getting unwrapped, that's all kind of going through Calyptra and interlock. So the two are very, very tightly coupled right now. And lock is an RTL implementation, just like Calyptra. These are very small implementations in RTL, so they don't consume a lot of area. But it is an RTL implementation that builds on top of Calyptra.
Brian, this is Ari again from Seagate. Jeff Anderson's talked about SPDM attestation, which I think is a great concept. Do you see that as being a requirement, or just something that's nice to have in the future?
I think SPDM attestation is a way to get measurements out, for sure. So I think SPDM as a protocol is great. How those measurements occur and how those operations are bound together. That's what Calyptra and Lock solves. SPDM is like the protocol that runs on top, if that makes sense.
Yeah. It just makes it easier to manage.
Yeah. Was there more questions?
I have one comment, and it's about the timeline here, because if we have to wait for everybody in the industry to get in lockstep and maybe adopt Calyptra and adopt a lock, maybe that's 2 or 3 years out realistically. Then those drives go through their life cycle, which for some drives will be 5 to 7 years. It kind of feels like we're 10 years out before we get to a circular economy for hard drives. Do you see opportunities to get there earlier for some cases?
I certainly hope so. And I'm kind of given hope by some of the things that we talked about today with OCP Safe. I think maybe we can start down that path sooner. But, I don't see this happening overnight. The damage that's been caused from competing at this level and trying, some folks take delight in their competition stumbling on something, not realizing that they're just as equally impacted by the failure of a peer. So I think it's not something that we're going to solve overnight. I think we're going to have to move here. We'll move, of course, as fast as we can. But yeah, changing, what we have to do first is win mind share. And when we win mind share, we can get away from this. We can get away from this shredding of devices. Until we win back the mind share, this status quo, I don't see changing.
Do you see a bifurcation between HDDs and SSDs, for example?
No.
No.
Yeah.
Okay.
See,
Yeah,
I
Brian,
see.
question for you. You know,
It's good.
as part of like say a hyperscale qual, you know, could there be something you require from the vendor, like a certification of sanitization from one of these third-party test houses, or forensic analysis, or the OCP Safe program analysis, or their test plan and validation of sanitization with how they implemented it, how they tested it, how they know that it worked? Would that help, or are you guys doing some of that today?
Yeah, I think taking it into, we certainly do that today in test qual, but I think taking it to safe is and trying it through OCP Safe is one that would give the most confidence. Because I can stand on my chair and yell to customers that drives from vendor X are secure, trust me, they're secure, but at the end of the day they don't want to trust me either, right? We're moving towards a zero trust model, so we've got to win back mindshare and mindshare in people and in the industry, and the only way we do that is really by working together on solutions where we can have provable security. And I think I like the suggestion, and I really like the suggestion on OCP lock. I think it's potentially a path to get there soon. Or sorry, OCP Safe. I think it's a path to get there sooner. I don't know how fast the industry will move to it. But of course, the more transparent we can be with these things, the more we can prove that it is secure, the more mind share we win.
One more thing, Brian, actually on your reply to Ari. So you mentioned that currently you don't see a difference between SSDs and HDDs, right, with respect to this. Considering that we are sort of looking to reuse the devices, and that is one place where sanitization becomes very important. Do you think there should be, or there could be, a difference in approach based on the fact that one of them might have more probability or more probability of a second life than the other?
I actually think they both have the opportunity for a second life. I actually think they both do have the opportunity for a circular economy. I think the arrays is more complicated on one than the other. I think I think it's all been tarred with the same kind of lens of people are just of the opinion right now that these arrays mechanisms don't work, and I think that notion goes quite far in the industry, and until we can start to change that mindset, it's going to be very, very difficult for us to accomplish sustainability goals. And I don't want to discourage anybody, and I think we absolutely can, but we kind of need that verifiable program to say that, to start to come out and have reputable people stand behind the robustness of the implementation and good test criteria that can prove it so. And then of course we can also layer mechanisms, right? To say, we've got the crypto arrays, we've got that down, that's very good. You can have crypto arrays, you can also have then a second form of arrays, like block arrays, and we can make all of this cryptographically provable. I think that part is key as well. One of the big fallacies of this shredding of material is it's not cryptographically provable. You're trusting that the the cloud service provider or the technician in the data center did the right thing. And really it's, that's very hard to prove. Whereas if we go down the path of a verifiable crypto arrays, verifiable block arrays, and an attestable crypto arrays and attestable block arrays, we can actually go further than what this mechanism can provide to anyone. These shredders can create dust, but what they're creating dust out of, we can't prove to anybody without them having to trust the CSP or the handler of the device that they've actually taken it and crushed it. And that's where the root of trust can give cryptographically verifiable, guarantees that the event that we said happened, such that the data got destroyed, that actually happened. And I think I already mentioned, hey, Jeff Anderson was seeing if we could get something through SPDM. Yeah, that's exactly, the path. We're looking at ways we can get verifiable attestations that these crypto arrays is completed, or not just crypto arrays, the block arrays completed successfully. Oh, hang on a sec. Give me 1 sec. All right, back. Let me get back to the to this presentation. Can you guys see it? We're back? Not back?
Not yet.
No, I might have to reshare it. Hang on. And we're kind of running up against your guys' precious time. So you can see it now?
Yes, it's back.
All right, awesome. Let me just move to, I've got a couple more slides on that. Oh, geez, did it go? We still here?
It went.
You did
Can't
lose
see
it.
it.
All right. We're back. Maybe. Might have to reshare. Let me see. Window.
As we're waiting, Brian, this is great stuff. Thank you so much for coming here.
Oh no, you're more than welcome. Thanks for having me here. Can we see that one slide again?
Yeah.
We can.
All right. Let's just move to what we got. So we know the current method today is not sustainable. It doesn't achieve zero trust. Nobody knows what's getting shredded. As a cloud service provider, I can tell everybody we shred everything before it leaves our data centers right now. I cannot cryptographically prove that to you. And that's a problem for customers. We can move towards cryptographic proof, which would be if we do the right implementation on devices, on storage devices, we can get the cryptographic proofs that the device has had, whether it's crypto arrays, block arrays, or both. We can get there. And I think that's really valuable and goes beyond the, creating the dust pile. Renewable security primitives, I think, are really key in the second life as well, when we want to move stuff to the circular economy. So like secure boot keys, anti-rollback fuses, those two have to be addressed. To a more sustainable model to move to a more sustainable model. I think we need to get to multiple forms of standardized secure arrays. We do have the crypto arrays. We're doing an implementation of that in Lock, as I mentioned, which captures all the things people come and question us about. Is it erased if somebody enables debug on the device? Is it erased if they come out with scenarios, right? If the firmware is rolled back, does the key get erased? The different folks have different questions on this. And we're coming out with a very robust implementation. We'll also, my takeaway from today and the feedback today is to go work with the OCP SAFE to ensure that we start to test to all of these criteria as well. We do need to get to something measurable in terms of block arrays across the same scenarios, where it doesn't just start the sequence and say it's complete or it's in progress, but actually completes thoroughly. And then, you know, with the block arrays, that you know, we need to establish 2 criteria around it completing properly, like what happens with, you know, the bad blocks, and you know, what if it's, you know, what's allowed not be erased, you know, if it is a bad block, and you know, is it acceptable if 1 bit in that block can't be erased? Maybe. You know, is it acceptable if there's a distance between the bits that can't be erased? You know, no meaningful data can get recovered, especially if crypto erase happens too. Maybe, but I think we need to start to establish some of this criteria, right? And put that in, and then we can do tests to that criteria. And then, as I said, a tested arrays is absolutely essential. I can't overstate the value in having proofs that the event took place. And that's really all I got.
Brian, thanks so much for spending this hour with us. Obviously, a topic that there's a lot of interest in. Any final questions or comments for Brian before we close?
No, this is great. I think we're looking to OCP leadership and this collaboration between security, sustainability, and storage projects to get this figured out. And I think we really need all 3 involved.
Yes, absolutely agree with James' comment here.
Yeah, absolutely. We'll send out those slides too, and we'll take a follow-up action too. I'd really like to take this to SAFE and see what can be done there. We can talk with OCP leadership too on that. And see if we can start to drive some kind of a certification, or I don't like to say certification, maybe like a qualification of it through SAFE, where we can start to establish, you know, sustainable drives or renewable drives. We'll come out with some phrase that we can put on them if these implementations are correct, and then we can start to move towards being wiser about how we do these things.
Yeah, Brian, one last question or idea is, you know, we get a lot of virtual returns. Everyone does, you know, drives that we give you credit for and you dispose of. My comment about having to wait 10 years, you know, if virtual returns could become part of this program, wow, you know, that would really invigorate the storage industry.
Yeah. We're motivated too.
Yeah, motivated. Yep.
Yeah. You know, because we do have a class of customer, like the zero trust guys, shredding a drive is meaningless to them. They don't know whether you shredded that one or you shredded, you know, it's not an attestable event. So as we move towards that too, and confidential cloud and zero trust, these mechanisms, it's not only they have to change for sustainability, they actually have to change for practicality purposes, right? Or we have to find a way of providing proofs that, you know, a pile of dust can't tell you that it's been cryptographically erased or that it's been securely erased. So, yeah.
Yeah, doing some quick math in my head, I don't want to see another billion drives shredded before, you know, we get something going.
Yeah, I hope not either. All right. Thanks a lot, folks. Thanks for letting me come here and give me
Great
the time.
discussion. Thanks, Brian.
Yeah, thank you again, Brian.
Thank you so
Thanks,
much, Brian.
everybody. And we'll
right.
see you next month.
Take care. Bye.
Thank you,
Bye.
folks.
Bye-bye.
Bye-bye.